Okay, everybody say hi. A little more enthusiasm. No, that wasn't much more enthusiasm. All right. So, okay. So I'm going to start this discussion here with a triangle. And I'm going to call this, there's a right triangle. So I'm going to, even though it doesn't really totally match up size-wise, I'm going to call this a 3, 4, 5 right triangle. Do you remember 3, 4, 5 right triangles? Right? It's a special triangle. Any right triangle has a 3 or a 4. It also has a 5, or it has a 3 or a 5. It also has a 4. It always comes in those measurements. Actually, I'm going to start someplace a little bit different. We're going to come back to that. 6 trigonometric functions that you need to know. Sine, cosine, tangent, cosecant, secant, cotangent. I will spell them out. It's S-I-N-E, it's not sin. It's cosine, tangent. Did I told you my math joke?
Yes.
I did? Oh yeah, you knew the answer to it, right? Did you get my other math joke the other day in the email? Anybody see that?
Oh, yeah.
Yeah, how do you put 5 into 4, or 4 into 5? 4 into 5. Trust me, that actually came from my niece. Okay.
Oh, it's gonna be too long.
It's like this. F, I, V, E. Get it? Secant and cotangent. Now the fact is, although you'll want to know all of these in many different varieties and forms, you really only need to know 2 of them. If you know sine and cosine, you can derive all the other trigonometric functions. What is this mysterious sine and cosine? Do you recall SOHCAHTOA? Okay. SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So I'm going to call this angle right here angle theta. And so, Sarah, can you tell me what sine theta is?
4 over 5.
So sine is opposite over hypotenuse.
3 over
3 over 5, right? The side opposite the angle over 5. We good with that? So sine, all it is a ratio of sides of a right triangle. What about cosine theta? Oh, Hannah, cosine theta.
That would be 4 over 3.
So cosine adjacent, the side adjacent to my angle here, over hypotenuse.
Oh, so 4 over 5.
So be 4 over 5. Are we okay with that? Yeah? Okay. And Victoria, what would tangent be?
3 over 4.
Or opposite over adjacent. Right? 3 over 4. Tangent theta is 3 over 4. So let's just take a little break here, because I said all you need to know is sine and cosine. So I want to know what is sine theta divided by cosine theta. sine theta over cosine theta. What sine theta? 3 over 5, right? Sine theta is 3 over 5. And cosine theta is 4 over 5. We okay with that? 4 over 5. So I have a fraction over a fraction. I need to get rid of this denominator here, so I'm going to multiply by its reciprocal, 5 over 4 on the top and the bottom. That becomes 1, right? And this becomes 3 over 4. Is that right?
Yeah.
And what do you know? Sine over cosine is the same thing as tangent. So that's why I said if I know what sine is, and I know what cosine is, I can easily find out what tangent is. I just divide sine by cosine. That make sense? Okay. So, but Mr. Jenkins, there are 6 functions. You only gave us 3. Because these are simply the reciprocal of their pair. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. So if I know sine and cosine, I can find tangent. And I can do the reciprocal of all these. And I've got all 6 trigonometric functions. Piece of cake. So somebody was saying, well, why didn't they put secant with sine, right? Because they both start with S. And why didn't they put cosine with cosecant? Could it be C and C, right? And the reason we came up with is because they're being rude. So if you wonder why they didn't do that, it's because they're rude. But unfortunately, the C does not go with the C, and the S does not go with the S. They're switched. So just remember that they're switched, and you'll be okay. Okay with that? Okay. Back to my triangle. So instead of a 3, 4, 5 triangle, I'm going to change it. I'm going to call it a 6, 8, 10 triangle. 6, 8, 10 triangle. There's nothing wrong with the 6, 8, 10 triangle. They work just as well. So Valeria, can you give me sine theta for my new 6, 8, 10 triangle?
6 over 10.
So sine theta is 6 over 10. Can you reduce that?
Okay.
Doesn't change. Doesn't change. Doesn't matter if I make the triangle bigger or smaller, because the trigonometric functions are the ratios of the different sides. And if I'm making one side twice as big, I'm making all the sides twice as big. Yes. Okay, so Alexis, give me cosine theta now.
8 over 10.
8 over 10, which I can reduce to.
4 over 5.
Further proof. Doesn't change. We okay with that? Yes? Okay. Now, if I take my triangle here, I just take my triangle here, and I turn it. Does my sine and cosine change? You sure? I turned it. No, same old, right? Doesn't matter, because it's the ratio of the angles, right? I could turn it as many times as I want, and it's still going to be the same. Isn't it fun? That's so much fun. Okay. Right. Good. We're good with that? This part's good? Okay. Let me just stop this for a second here and